All right, in 7.2, let's take a look at properties of parallelograms. Hopefully you have an idea of what a parallelogram is, something that's in the word parallel. Hopefully that should tell you that, hey, opposite sides are parallel to each other. A parallelogram has four sides. Some other things that maybe can come to mind that you already know. Um, Opposite sides happen to be congruent. Uh, and let's see what some of these other ones are. Okay, so we have our theorems here to kind of go over the other details of a parallelogram. First off, if a quadrilateral is a parallelogram, then its opposite sides are congruent. All right, so what they're showing you here is that PQ, SR, those are congruent. QR and PS are congruent as well. So opposite sides theorem for a parallelogram, opposite sides are parallel. Pretty simple, right? Let's take a look next up at 7.4. We have the parallelogram opposite angles theorem. It says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So you can see that angle P right here, congruent to angle R. Angle Q is congruent to angle S. Okay, so opposite angles right here are congruent in a parallelogram. Okay, and if you think about why, remember we learned earlier on when we did our theorems about parallel lines cut by a transversal, and thinking about the angle pair relationships that occur. Next up, we have theorem 7.5. We've got the parallelogram consecutive angles theorem. And right there it says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So what they're saying here is that angles Q or X and Y right there, those are consecutive angles. They are supplementary. Y and X, those angles right there are supplementary. And even across the top, right, I can say that angle Q plus angle R, those two as well are supplementary. They equal 180. And so do the ones down below. Angles P and angle S is also equal to 180 degrees. Okay. Next up, theorem 7.6. Make sure you guys have these theorems all written down in your notes. We have the parallelogram diagonals theorem. And it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so you can see right here, they show that QM and MS is congruent to PM and RM. All right, parallelograms, diagonals are congruent. All right, that leads us to being able to solve out our problems here. Start off, we take a look at number one. Looks like they have some exterior sides listed, and it says we have to find right here the value of each variable in the parallelogram. And since they told us that these are parallelograms, we will use the theorems that we just learned to help us solve these. All right, so to start off with, one of the things, if they gave us outer sides, we should know that opposite sides are congruent in a parallelogram. So I go ahead and let's take x plus 18, and let's set that equal to 3x minus 2. I'll go ahead and get x by itself. I'll subtract x to both sides, and I have 2x, and I'll add 2 to both sides, and that's equal to 20. Divide both sides by 2, and x is equal to 10. So I went ahead and found that first, because if I try solving for the opposite sides I just put in magenta right there, we have y is equal to 4x. Well, I can't solve anything there because I don't know one of the variables. There's two variables. But now that I know what x is, I can go ahead and substitute that in right here. Put 10 in for x, and then y is equal to 40. And now we have found each variable. Let's take a look at number 2. On number 2 right here, looks like I'm going to have to take these two angles that are congruent because opposite angles are congruent in a parallelogram and set those two equal to each other to help me find x. So I got 49 is equal to 4x minus 37. Okay. We'll go ahead and add 37 to both sides, and 4x is equal to we've got 86, and x is equal, dividing both sides by 4, x is equal to 21.5. Now that I figured out what x is, let's go ahead and solve for y. So remember, opposite sides are congruent, so I can go ahead and put right here that y over 5 is equal to 4x. But instead of x, now that we know what x is, let's go ahead and plug in right here 21.5. And then we have right here after that minus 3. We could simplify things on the right-hand side first, and then go ahead and get y by itself. So you take your pick. It looks like right here, if I take, let's see, we got 21.5 times 4, that's 86. So if I have right here y over 5, 86 minus 3, that'll get me 83 right here. And then for our last step, we'll multiply both sides by 5 so that we can get y by itself. And so y is equal to 415. All right, so we now have x and y. For our last piece right here, when we take a look at number 3, this is a parallelogram. So what we know about parallelogram is that the diagonals bisect each other. And I went ahead and marked things up and showed which two sides or which segments are congruent to one another. So we can go ahead and solve now for x and y. For x, we got 2x plus 10 is equal to 4x minus 2. We have 2x is equal to 12, and x is equal to 6. We will repeat this process for y. And so I can go ahead and put 3y is equal to 5y minus 16. I'll subtract 5y to both sides, and we got negative 2y is equal to negative 16. And then when we divide both sides by negative 2, y is equal to 8. All right. We found each value of the variables in the parallelogram. For our last one, we have 11 different problems or examples to look at right here. We have a parallelogram, and we are going to need to explain your reasoning on why you chose your answer for each. Okay, so let's see if we can do that right here. For number 4, where they're asking us, what is P to O? I'm looking at P to O. if this is a parallelogram, opposite sides are congruent, so P to O is 24. Give me a reason. We can go ahead and say parallelogram, opposite sides theorem. Okay, so make sure you put the reason down. Parallelogram, I'll use a diagram, opposite sides theorem. All right. Let's take a look at number 5. We have O to Q. Okay, O to Q right there. From what I know, that should be, remember, diagonals bisect each other. So O to Q should be 14. Right here, parallelogram, diagonals theorem. We have next up, we have N to O. All right, N to O right here. Opposite sides should be congruent. So N to O is 26. And we have ourselves, once again, parallelogram, opposite sides theorem. Next up for number 7, they're asking us for P to Q. Okay, so that looks a little familiar again. P to Q is right here. I should know that diagonals bisect. So if Q to N is 20.7, P to Q is also 20.7. And we have parallelogram, diagonal theorem. How about number 8 next? We have angle PMN. Angles PMN. All right, so we're looking at this angle up here. Okay, so looks like we're gonna have to do some work. We don't have all the information, it looks like, in order for us to get our answer quite from the get-go. Let's see. They show us that this angle over here is 68 degrees. So remember, these two angles, if it's a parallelogram, our two consecutive angles should end up equaling 180 degrees. They're supplementary. So what I could do is put angle PMN plus angle MNO is equal to 180. And so what I could do is go ahead and put that as x plus MNO is 68. And that's equal to 180. And then find x by itself now. And then from there, I go ahead and find that x equals 112 degrees. So what could we go ahead and say? We got parallel. Say the parallelogram, consecutive angles theorem. How about that? All right. So now we have found the number 8. All right. Number 9 says angles NOP. Angle NOP. All right. So let's see what we could do right here. NOP. Now that I know. Okay, let's see. One of the things we could say is that opposite angles, there's multiple ways for us to go about this problem. But one thing that we do know is that these opposite angles are congruent. If PMN, right, we just determined that that's 112 degrees, then this angle over here needs to be equal to 112 as well. Angles PON needs to be equal to 112. Okay, so they asked for OPM. Let's see. Actually, even easier. Remember, these two angles, actually, let's not even look at the opposite one. Let's look at this angle right here. Okay, that's what we're going to need to look at. This angle right here and the one above it, PMN, should also be supplementary. So we can go ahead and take 112 plus right here, OPM, which happens to be the angle we are looking for. And that's equal to 180 degrees. So as we go ahead and solve that out, we can go ahead right here and find that angle OPM is equal to 68. All right. Looking good, right? So that right there is equal to 68 degrees right there. For NOP, for this one, for number 9, let's go ahead and put parallelogram, opposite angles, congruent. For number 10, for our answer, we can go ahead and put, we could also say, I could have looked at the angle opposite of it, but with how I solved it out, parallelogram, consecutive angles theorem. But I could have also looked at the opposite angle and come up with my answer as well. Last up, let's take a look at number 11. They're looking at angle NMO. Okay, so we're looking at NMO. That happens to be, okay, so we're looking at this angle right here up at the top. And it's only like part of the angle, right? So how am I going to figure that part out? Well, remember, we have parallel lines, boys and girls. So if I go up, I'm going to drag it up a little bit, and let's draw a few things. I've got parallel lines right here that I'm drawing with purple, and we have this segment MO as your transversal. Take a look. This angle right here and this angle right there, and let me highlight it for you so you can go ahead and see it. What are the relationships between those two angles? We have alternate interior angles, congruent. So this angle MNO is equal to 59 degrees. And we have now figured out all the different angles inside and out of a parallelogram. All right, make sure you guys have your, take notes on these, and maybe I'll give you a flow chart later on so you can gather your information, because there's a whole lot of different quadrilaterals that we're going to be looking at. And this is just the beginning right here on properties of parallelograms in section 7.2.